All right, we're now with common and natural logarithms. So when you say, excuse me, when you have a common logarithm, that means it's the log of a number to the base 10. And usually what you do, you drop the 10 here. You don't write it anymore. So if you say the log of 100 is equal to 2 because 10 raised to the second power is equal to 100. Okay? The natural log is the log of base e. So the natural e, it is written as ln or natural log instead of log. For example, the natural log of x equal to 5. Okay, so that means here it's understood that the base is the natural e. Right. There are basic properties of logarithms, and these are very important to make sure you read it 100 times, you internalize it as much as you can because they're very, very useful, especially the common logs and the natural logs. Okay, so when you say the log of b to the base b is 1, that's just natural because what did I raise b to get b? Well, it's 1. Give you an example. So we say, what is the log? Say, what is the log of 3 to the base 3? It's 1 because what did I raise 3 to get 1? So 3 raised to the 1 is 3. What is the log of 4 to the base 4? It's always 1, etc. Because I need to get 4 itself, it's only raised to the first power. Okay, now what about the log of 1? When you say the log of 1 to the base b is always 0, again, write it in exponential form because, all right, in this case, b raised to the what? 0 is always equal to 1. So for any base, say the log of 1 to the base 2, that's always 0 because 2 to the 0 is 1. The log of 5, the log of 1 to the base 5 is always 0. Anytime, for whatever base it is, the log of 1 is always 0. Now here, these two are kind of like inverse operations of each other because when you say the log of b to the x to the base b, it's like this is canceling out the operation of the logarithm because it's raising it to the exponent. And remember, the logarithm is asking for what's the exponent that I raised b to get b to the x. Naturally, it's going to be x. Okay, so if you see this, it's kind of you drop everything. Same thing, b to the log of x to the base b, you get x back. Okay, so these are kind of like inverse operations of each other. Same thing here. They're inverse operations of each other, so you get x back. Okay? So let's just translate all these to the common and the natural log. So the log of 10 to the base 10 is 1 because what? 10 to the first power is 10. What's the log of 1? 0. The log of 10 to the x is, again, that's like canceling out. You get x back. 10 to the log of x, you get x back. Again, it's kind of like canceling out because you're performing inverse operations of each other because the logarithm and the exponential are inverse operations of each other. So the natural log of e is 1. This is important. These two are very important because they'll pop up when we solve equations. The natural log of 1 is 0. Natural log of e to the x, again, that drops, and then you just get x back. Same thing. E to the natural log of x is always equal to x. So again, that drops because you're performing inverse operations with each other. All right? Okay, let's see if we can evaluate each of these. Now, what do you say? What do you mean when you want the log of 0.001? Remember, 0.001 is the same as what? 1 over, right? 1 over 1,000. Okay, which is the base 10. So that's the same as the log of 10 to the what power? Negative 3. So remember, when you have the log of 10 raised to any power, you just drop everything and that's equal to minus 3. Okay, which does make sense. What did I raise 10 to get 0.001? Negative 3. Okay, now here, it's a bit tricky, but it will work out. Okay. So here you write this as the natural log of e raised to the what? Write this in exponential form, 3/5. And remember, whenever you have the natural log of e to the something, this drops and your answer is just 3/5. Okay, so go back to the previous slide. Remember, the natural log of e to whatever is that whatever. So the natural log of e to the x is equal to x. So here, the natural log of e to the 3/5 is 3/5. So this basically what happens is like you're dropping this because you're performing inverse operations with the natural log and the natural e. Okay, what about letter C? Letter C is entirely different though. Let's see. Probably we're going to have to, it's not straightforward, but how do we look at this? Well, suppose we don't know what it is, right? Let's call it x. Okay, so you say that the the log of 3 to the base 81 is x. So if you don't know what x is, write this in exponential form. So what does this say? 81 raised to the x is equal to what? 3. Okay, so when you're in a log form, write in exponential. And then remember that 81 is a power of 3. It's 3 to the what? 9 times 9, so that's 3 squared times 3 squared. So 3 to the 4th raised to the x is equal to 3 to the 1. So you've got that same base. So far, what do we have? We've got 3 to the 4x is equal to 3 to the 1. And once you have same base, you can drop those and equate the exponents. So that's section 7.1. So 4x equal to 1. So therefore, if you divide both sides by 4, you get x equal to 1/4. Okay, which kind of makes sense because you're asking, what is the 4th root of 81? Because 81 raised to the 4th root, you get 3. Okay? All right, what about this one? Okay, there are different ways of doing this. You could either write this in terms of the powers of 2 or rewrite it in exponential form. How about if we rewrite in exponential form? So write in exponential form. Okay, so let's do that. So how do you write in exponential form? We say 2 to the 5th is equal to 16 to the x. And then we're back to same base problem. So you want to write 16 in terms of base 2. So 2 to the 5th is equal to what's 16? That's 2 to the 4th. And then raised to the x, so 2 to the 4x. Okay, so now that we have the same base, we can just set the exponents equal to each other. So we say 5 is equal to 4x. Therefore, if you divide both sides by 4, you get x is equal to 5/4. Okay, so that's one way of working that. Or you can apply the principle that we have if you raise this to the 2 powers of 2, but I think this is the easiest way to do it. Okay, all right, next slide. Right, what about this one? Again, we could do same base formula here. So you've got 7 raised 7 to the log of x to the base 2. Remember, we can't drop the x here because that's not 7 right there. But what we're doing is you want to make sure you have the same base. So 7, well, how do you write 49? That's 7 squared, see? Okay, now we can drop the bases and equate them to each other. So now we're going to equate this to each other. So we'll be getting the log of x to the base 2 is equal to 2. And then from here, what do we do to find x? We rewrite it in exponential. So write in exponential form. What is the exponential form of this equation? You say 2 raised to the 4th is equal to x. Therefore, 2 raised to the 2, my bad. Okay, because my brain's already thinking ahead. So 2 raised to this 2 is equal to x. So therefore, x is equal to 4. Okay, now let's see if that even works out. What is the log of 4 to the base 2? The log of 4 to the base 2 is 2. So this whole thing is equal to 2. So 7 squared is 49. So it does check. All right, how about this one? How do we solve for x? So every time if you see that you can't work your way out, remember, no way you should treat this as dividing both sides by logarithm. No, because this is a single entity. So you're looking at the logarithm, you're evaluating the log of 4x. Whenever you don't have a base, it's understood that there's a 10 there, base 10. So go ahead and write that down just so you would be able to translate it into its exponential form. So write it in exponential form, and what do you get? You get 10 raised to the 1.8 is equal to 4x. There you go. So now it's a linear equation. Divide both sides by 4, and you'll just have to use your calculator here. Okay, and I believe it's going to be equal to 15.77 if you're asked to write it in 2 decimal places. Okay, all right, so that's your approximate answer. Basically, this is the exact answer, and then once you use your calculator, then you get this. Okay, now here, what is this? All right, again, you have a logarithmic equation where the unknown is in the argument of the logarithm. So what do you do here? Every time you have an unknown, the variable x is in the argument of the logarithm, rewrite in exponential form. So write it in exponential form, which is what? Okay, 9 raised to a half is equal to what? 4x minus 5. Okay, so and then you can just simplify 9 raised to a half. That's just saying what is the square root of 9, which is 3. So 3 is equal to 4x minus 5. Add 5 to both sides. We see that 4x is equal to 8. Therefore, x is equal to 2 once you divide everything by 4. So x is equal to 2. And I guess that concludes section 7.3, and always check your answers. I guess we can easily check it, all right, but I want you to check it because your answer here should be what? It should be 3 because 9 raised to a half is equal to 3. So if you plug in x equal to 2 there, you get 8 minus 5 is 3. So the log of 3 to the base 9 is 1/2 because to raise 9 to a half, you get 3 back. All right? Okay, that concludes 7.3.